Hello, welcome to Combining Functions Algebraically. I've got an example already started here where I've got two functions, f and g, and I'm going to combine them not by looking at a graph and saying, hey, let's figure out y values and see what kind of combination y values we get, but rather I'm just going to do it algebraically. So let's say I combine these into a kind of a new spliced function, and it's going to be f divided by g. What's that going to look like? Well, there's function f, okay, on the top, and it's being divided by function g. Okay, so x plus 1 squared. Well, gee, that's about all there is to it. I look at this and I go, there's no way that I can simplify that or cancel anything. So that's about all I can do with that one. That's my combined function. And the only thing that might be nice to know is there a certain domain or restrictions? Well, in fact, there are. First thing I notice is I'm square rooting x plus 2, which means that x plus 2 has to be greater than or equal to 0. Or, and to put another way, x has to be greater than or equal to negative 2. Anything less than negative 2, and it's going to go negative. So that's a definite restriction there for all of the x's. And further to that, I also notice that because this function here is a denominator, I can't ever let it equal 0, which means, in addition, so comma, x cannot be allowed to equal negative 1. Okay, which would have been, if I only had the stuff from the square root stuff, we would have thought negative 1 is okay. But when we looked at the function on the bottom, the negative 1 has to be rejected. So that's our domain and range for that combined function. Okay, on to our next example. Next example, we have function f and function g. Very creative titles for these functions, but I guess they're better than nothing. So there's function f, and here comes function g. Function g is 3x squared minus x plus 6. And what I want to do is I want to combine these in the following way. So we're going to figure out g of x minus f of x. Okay, so all I'm going to do is I'm going to take function g and write it first. So 3x squared minus x plus 6. And then it says I'm subtracting, so I got a minus function f. Now here's the trick to this one. Make sure you put brackets around all of function f, because we are subtracting all of function f, not just one part of it. Okay? So that's kind of the common mistake, is people miss the brackets. But it's important that all of this is function f, and that's what we want to subtract, the whole thing. So yeah, now we can combine some stuff. 3x squared minus x squared, so there'd be 2x squared, a negative x, and a double negative, so it's plus 2x. So that looks like it's going to be plus 1x. And then I have 6, and then again a double negative here, so it's like plus 1, so that would be 7. So that's my simplified combined function. Okay, I have one more example, and then I'll stop with the algebraic combinations. My last example, I have a function f, and it is a fraction, x minus 1 over x plus 2, and over here function g, which is also a fraction, x minus 3 all over x plus 5. And here's what I'm going to try to do as my combined function in this example. Take function g and divide that by function f. See what that looks like. Okay, well, function g is this whole mess, x minus 3 over x plus 5, and that's all over x minus 1 divided by x plus 2. So now the question is, how do I simplify this? Well, let me show you. Remember that fractions mean the top divided by the bottom. So why don't we just write these side by side and say there's the top, and I'm going to divide that by the bottom. Okay, it makes it a little bit easier, I think, if you write them side by side. And then you look at it and you say, you know what? How do we divide fractions? We multiply the reciprocal. So I'm going to flip the second one over and change from division to multiplication. So x plus 2 on the top, x minus 1 on the bottom. And the only other thing I can think to do is maybe write it as one big fraction. You don't even have to expand out the brackets unless you really wanted to, but I don't think there's much gained in doing that. Usually the factored form is preferred because then you can spot things like the restrictions a little bit easier. Speaking of which, what are the restrictions on this thing? Okay, well, let's have a look. Okay, the restrictions are on x. What can't x equal? Well, clearly negative 5 and positive 1 are out of the question. Okay, so that's what we got to throw out. And then, is there any time where there was any other number that was part of a denominator? Oh, right there. There's an x plus 2 as the denominator, so negative 2 is bad. Now, we already analyzed the negative 5. So negative 5, negative 2, and then there's the 1. So we got them all. These are the restrictions on this particular combined function. And that's where I am going to stop. So we'll catch you later.